welcome. So in this video we are going to give you some shortcuts, not very scientific, not very rigorous, but useful for exam purpose. Okay, so let me write non-rigorous shortcuts or short derivations for op-amp based amplifiers. For that means the three amplifiers we have studied so far: inverting, non-inverting and difference. Okay, so this shortcut is based on the assumption that virtual sorting is true, is happening. The two input terminals are virtually sorted. It is based on that assumption. Okay, so let's start with the difference amplifier. Let me draw it very quickly. So draw the op amp, put minus and plus signs, then connect the negative to the output NO, positive to the ground PG. These are the two inputs. So these are the two inputs, okay, and they are at potential V1 and V2. This is the output VO. An ideal difference amplifier should have these two resistances same value and these two resistances of same value. This is an ideal difference amplifier. Right now I do not bother whether this is connected with a common ground configuration or in a differential input mode. I am not also drawing the power supply and detailed ground connections, etc. Those are required for real life when you work in lab, of course, but this is a shortcut. Okay, this is a non-rigorous shortcut. So this point is at an absolute potential V1, V2. This is VO, and we assume that these 2 points are at the same potential. Vn is equal to Vp. Assume virtual sorting. That means Vp is equal to Vn. With this assumption, we can find the expression of output very quickly. How? Let's see. Okay. So if this is V2, then this point, using potential divider rule, I can write directly. This will be V2 divided by R1 plus R2 multiplied by R2, potential divider rule, and then this should be same as Vn because of this assumption. So this is equal to Vn. Okay, fine. Now Vn is how much? Vn is nothing but, once again, a kind of potential divider rule or Millman's theorem, if you know, or you can find the current and then multiply the current with resistances to get this drop, and then what you will find is this. Okay, applying circuit theory in this part, you can find that this is nothing but equal to V1 multiplied by R2 by R1 plus R2 plus VO multiplied by R1 plus R2. Okay, now you can put the value of Vn, which is this. Okay, so Vn is this much, so let me put this value, V2 R2 by R1 plus R2. Okay, now from this you can so just consider this part, and you see denominator is common, R1 plus R2 everywhere, so you can cancel it everywhere. So you can write directly V1 R2 plus VO R1, only the numerator, is equal to V2 R2, and from this you will get VO is equal to V2R2, this minus this, divided by R1. With some small step jumps, we get this very quickly. Okay, so this is a shortcut, right? And the key thing is that we have assumed this virtual sorting. So a key important thing is that this virtual sorting, I told you, it's not true always. It depends on the circuit. It's not a property of the op amp. So for example, if you by chance make this plus minus inputs wrong, if you swap them, that will not work. So for example, copy paste okay. So for example, here if you swap these plus minus signs like this, you make this plus, this minus, then this is wrong. Wrong in what sense? Wrong in the sense that virtual sorting is not going to work. Okay, virtual sorting will not work. What I mean is that Vp is not going to be equal to with Vn. So only if you remember this circuit correctly with all plus minus signs proper, then you can, then we have previously shown with rigorous detailed analysis that virtual sorting is going to work. So you may just remember that the fact, okay, virtual sorting is going to work, Vp is going to be Vn, then you can do the derivation very quickly. Okay, so this is a shortcut. Now let's talk about, so let me also write a comment. Be careful about plus minus inputs. If you do it wrong, circuit will not work. In exam, your answer will be wrong. Now let's go to say inverting and non-inverting amplifiers quickly. So first non-inverting, or okay, okay, non-inverting. So I also have told you how to remember the circuit. You just have to remember this one, and then for non-inverting amplifier, that means this input, this will go to 0. So you can connect this point to ground, and you can give the input here. And then we have shown, okay, giving the input is same as giving the input directly here, because this is only a potential divider. Okay, so therefore you just erase it and give the input directly. Call it VI, I for input, and this terminal is going to be grounded 0. So this is the circuit. Now again, assume virtual sorting, Vp equal to Vn. If that is the case, then Vp is also equal to Vi. Okay, then what can I say about Vn? Vn, let's apply potential divider rule here. So this will be equal to VO by R1 plus R2 multiplied by R1, because this part is the current here. This is VO by R1 plus R2 is this current, multiplied by R1 is this voltage drop. So this is Vn. Now this should be equal to Vi because of our assumption, and then we can quickly write VO is equal to Vi multiplied by R1 plus R2 divided by R1, or you can also write it in this form, 1 plus R2 by R1. So this becomes very easy for exam. You can do it very quickly, this derivation, but be careful about the this plus minus sign. Okay, be careful about plus minus inputs. If you swap them, if you make this minus and this plus, that circuit, you know, virtual for that circuit virtual sorting will not happen. That acts as a Smith trigger, we told you. So then this analysis is not true. Okay. Now last thing, this inverting amplifier. Okay. So last thing is inverting amplifier. Quickly, I will always start from the circuit of difference amplifier, even if I remember it directly. Copy, paste. This is R2. Now this is inverting amplifier, means what? The input will come here at the minus terminal. So let me call this Vi, this is input, this is going to be grounded. Okay. Now if I ground this, this is also grounded, this is also grounded, so I can ground this terminal directly. Okay. So therefore I erase these unnecessary things and connect this directly to the ground. This is inverting amplifier. Now you can make the assumption that Vp equal to Vn. This is actually not an assumption. I mean, we know that for this circuit this will be the case. So it's better that I write that we know or we can prove or we have already proved actually. Okay. It's not an assumption, it's true for this circuit. Unless you make this plus minus sign opposite, then it will not be true. So be careful about plus minus inputs. With this proper plus minus inputs, this is true, Vp equal to Vn, and then what can we say? So Vp is 0. Okay. Vp is 0, so Vn is also 0, and if so, but we can also write Vn is nothing but equal to some sort of average of Vi and Vo with an analysis from this part. Okay. So we can write this is equal to Vi multiplied by this resistance, the resistance which is farther from Vi, divided by R1 plus R2, plus Vo multiplied by this resistance R1 divided by R1 plus R2. Now we know from here that this is equal to 0, so this is equal to 0. So from this we can write, okay, so that means this term is 0. Now the denominator is common, you can ignore, I mean you can eliminate it. So you write Vi R2 plus VO R1 is equal to 0, which will give VO is equal to minus VI R2 by R1. So simple. Once you make this assumption, I mean, once you start from this fact that Vp is equal to Vn. Okay, great. But be careful always about this plus minus symbols. Thank you.